Hey, I'm excited to be here. 2 years ago, we started working with a lot of our customers and deploying Edge, Kubernetes, and really understanding the challenges behind the deployments. So I'll walk you guys through that. And the second thing is, with AI, especially with training and inferencing, it's very clear that there's a very clear separation here. Inferencing at the edge has very clear benefits. Our customers are starting to bring that forward very rapidly. And that is another indication and driver for understanding why Kubernetes is super important at the edge. So let's run through this journey and understand the challenges and what are we doing about it. So let's see. All right. So one of the largest customers we have in the energy sector, they are deploying thousands of gateways, where these gateways are connected into these oil rigs, or they're actually at the well sites. And these well sites are collecting data. They are collecting data in real time, and the applications are being orchestrated via Kubernetes. And it's interesting to see that there's several things going on. One, the first and foremost challenge is that when you're starting to deploy and scale at that rate, you'll see more than several out-of-sync issues. You'll see connectivity and latency and bandwidth, where it's either 250 kilobytes of bandwidth or it's several tens of megabytes of bandwidth. And in these scenarios, the variations in how Kubernetes behaves changes. So there's a lot of configurability that has to be exposed, and that has to be done in sort of more real-time, more operational mode. And so it's almost like there's an operational mode of deployment of Kubernetes, there's a setup mode of deployment of Kubernetes, and it sort of starts to separate out how you have to deal with that in terms of deploying this in this environment. And these are harsh environments. So what we are seeing is, on top of that, our customers here are deploying AI apps. So Vision, the most widely adopted AI solution out there, is actually looking at red zone detection, PPE detection, hard hat detection. If you're standing on the oil rig, there's a lot of safety concerns, and our customers will try to ensure that they get alerted notifications. These notifications are going to the individual persons that may be operating here, or they may be going to some centralized place as well. And now bringing that together, if you're updating that Vision application because, hey, you're extending that use case for flame detection, it's a big deal. It takes several months to even sort of consider taking that challenge, deploying something new, and then making sure it works. Taking another use case with AI, you have where well site production becomes interesting, and you're trying to improve the yields. Packaging of these AI models and updating them becomes interesting because you're constantly looking at bringing data all the way back to the central cloud and then figuring out how to improve the yield. And inferencing at that point becomes super impossible. So again, the way that Kubernetes ends up doing it is either you have a disconnected state half the time, or you have a connected state some of the times. And now how do you sort of operate between these two worlds with Kubernetes? Continuing that, so let's keep the journey going. Next use case and the next interesting deployment for Kubernetes that we've observed is where, again, if you're going and deploying more than 10,000, 12,000, 15,000 clusters at the edge, where you're constantly monitoring the supportability, the serviceability of automotive capabilities of cars coming in, this customer actually was able to deploy this at scale. However, you run into sync challenges. etcd cannot keep up with the regionality, with the diversity of hardware, and then sort of bring it all together into an orchestration. On top of that, you're trying to shard different instances and trying to scale this across thousands of clusters. It becomes super challenging. So how do you sort of bring that forward? How do you sort of consolidate that situation also and sort of bring that into this? It's an interesting challenge for us. And what we've done is we've had to look at helping a customer tweak the parameters for the liveliness detection, not only on the hardware side, but then on the orchestration side, change the timers on the Kubernetes deployments as well. Continuing further,